Welcome to Understand the Math. In this video, we're going to learn about arithmetic sequences, what they are, the formula that you'll need to use, and how to apply it. We'll walk through examples to find the terms in an arithmetic sequence, and then examples where we'll find the partial sums of a finite arithmetic sequence. Let's begin by looking at the formula that you'll need to know. To understand the formula, we need to first understand what an arithmetic sequence is. An arithmetic sequence is just a list of numbers where the difference between consecutive terms is constant. Let me show you what I mean by the difference between consecutive terms being constant. Let's look at this example right here. To see if it's an arithmetic sequence, what we have to do is look at all the terms and see if there is a common difference between them. To do that, you can take the term on the right and subtract the term on the left. Our second term is 5, and if we subtract our first term, we get 3. And then we take our third term, 8, subtract our second term, and we get 3. And then if we continue that pattern, we have 11 minus 8 is 3. And then 14 minus 11 is 3. So this is an example of an arithmetic sequence because the difference between the consecutive terms is a constant and it's equal to 3. We can say that 3 is what we call our common difference. Let's now look at our formula. Our formula tells us that the nth term of an arithmetic sequence is equal to the first term plus n minus 1 times the common difference d. N is just our term number, and then, as we saw above, d is our common difference. Let's again look at our example up above to see how this formula works. The first term in our sequence was 2, so we can say that a1 is equal to 2. And then we can use our formula to find the second term. A2 is going to be A1 plus n, which is now 2. So we write 2 minus 1 times our common difference, which is 3. So this is equal to A1, which is 2, plus 3, which is 5. Let's do one more so you can really see how this works. A3 is going to be A1 plus n, which is now 3, so we have 3 minus 1 times our common difference, which is 3. We plug in a1 is 2, so we have 2 plus 2 times 3, so that's 2 plus 6 gives us 8. And you can see that our terms 2, 5, and 8 are the ones we had in our sequence. The really nice thing about this formula is you can find any term if you know the first term and the common difference. Let's now look at some examples where we're going to find terms of an arithmetic sequence. I've chosen a bunch of different examples that you might come across when you study this. Here's our first example. We are going to find the first 5 terms of the arithmetic sequence. We're given a formula for the sequence, and we're going to use this formula to find our terms. Our first term is a1, and it's equal to 7 plus 3, plugging in n is 1, so 1 minus 1, and this is equal to 7. We could have also just seen from the structure of the formula that the first term was equal to 7. Now let's find a2. It's equal to 7 plus 3 times 2 minus 1. This is 7 plus 3, which is 10. Now let's find a3. This is 7 plus 3 times 3 minus 1. So this is just 7 plus 3 times 2, which is 6, gives us 13. You may want to pause the video and go ahead and find A4 and I5 on your own. A4 is going to be 7 plus 3 times 4 minus 1. So this is just 7 plus 9, which is 16. And then lastly, A5 is equal to 7 plus 3 times 5 minus 1. So this is 7 plus 12, which is 19. The first 5 terms in our sequence are then 7, 10, 13, 16, and 19. The other way that you could have calculated these terms is to recognize that it's an arithmetic sequence and just add 3 to each term. Let's now look at our second example. In this example, we are going to find the nth term of the arithmetic sequence. Over here on the right in purple, I've placed the formula, and to find the nth term, we need to find A1 and D. Let's look at part A. We are told in this one that A1 is 8 and D is 3. We just need to find A sub n. I always suggest that you write down the formula first. This will also help you learn the formula. Now we can go ahead and find A sub n. A sub n is going to be equal to A1, which is 8, plus n minus 1 times D. Now, here's what happens in practice. Typically, the D, when you plug in a constant, gets written in front of n minus 1. So we're going to write this as 3 times n minus 1. So that's the nth term of our sequence. Let's now look at part B. This one's a little bit harder. We are given A1 and A4. Let's start by writing down our formula. A sub n is equal to A1 plus n minus 1 times D. We have A1, but we don't have D. However, we are given A4. So what we can do is we can use A4 to find D. We can write down that A4 is equal to A1, which is 5, plus n, which is 4, so 4 minus 1 times D. And this is equal to 17. So what we're going to do is we're going to take this equation and we're going to solve for D. Let's pull the 5 to the right. So we have 3D is equal to 17 minus 5, which is 12. Then we'll divide both sides by 3, and we get D is equal to 4. Now we can go ahead and write down our answer. A sub n is equal to A1, which is 5, plus D, which is 4. So we have 4 times n minus 1. And there is our nth term. Let's look at one more. In this example, we're given A sub 51 and we're given D. Let's write down our formula. We have A sub n is equal to A1 plus n minus 1 times D. Now let's see what we're given. We have D, and we're also given A51. What we don't have is A1, so that's what we need to find. Since we're given A51, let's write down that A51 is equal to A1 plus n, which is now 51, minus 1 times D, which we were given as 6. And A51 is 1,000, so we can set this equal to 1,000. And then our job is to find A1. We have A1 plus 50 times 6 is 1,000. So A1 is going to be 1,000 minus 50 times 6, which is 300. So A1 is equal to 700. Now we can go ahead and write down our formula. AN is equal to A1, which is 700, plus D, which is 6, times n minus 1. And there's our answer. Now that we understand arithmetic sequences, we're going to look at an example, and we're going to be given a sequence, and we have to determine whether or not the sequence is arithmetic. If it is, we want to find the common difference. Let's look at our first example. We know that a sequence will be arithmetic if it has a common difference. So I'm going to take our second term and I'm going to subtract our first term and I get -3. Then I'm going to take our third term, 9, subtract our second term and we get -3. And then our fourth term, 6, minus the third term, which is 9, and we get -3. This tells us that our sequence is an arithmetic sequence. So let's write down yes. And then the common difference is equal to -3. Let's now look at our next example. We're going to do the same thing. To see if it's an arithmetic sequence, let's take our second term and subtract our first term, and that's 2. So you're always taking the term on the right and subtracting the term on the left. Our next one will be 8 minus 4. That's equal to 4. So you can see right now, it's not going to be an arithmetic sequence, but let's just go ahead and go on just because I want to show you something else. 16 minus 8 is equal to 8. These three numbers are not the same, so we don't have a common difference. So we can say, no, this is not an arithmetic sequence. Instead, this is a different type of sequence. If we were to take our second number, 4, divide it by the first number, we would get 2. And then if we take our third number and divide it by our second number, we also get 2. And then the same thing, if we take 16 divided by 8, we get 2. So instead of having a common difference, this sequence has what we call a common ratio. And this is a geometric sequence. I have a video on geometric sequences that you might want to check out. Let's now look at some different types of examples. In these examples, we are going to be finding the partial sum of a finite arithmetic sequence. Let's first talk about what that is. A partial sum of a finite arithmetic sequence is just the sum of the first n terms of the sequence. We have a formula for this nth partial sum. It's fun to derive if you ever want to derive it. There's a lot of resources on that. I'm sure you could find that in an algebra book. The nth partial sum is called S sub n, and it's just n divided by 2 times a1 plus an, where a1 is the first term in the sequence, and then an is the last term in the sequence. This is a really great formula because all you need to know is the first term and the last term, and then the number of terms in the sequence, and you can find what the sum of the sequence is. All you need to know to use this formula is n, a1, and an. Let's look at two examples. In both of these examples, we are going to be finding the sum of a finite arithmetic sequence. Here's our first example. We need to find the sum of 2 plus 4 plus 6 all the way up to 20. Now you could probably do this one by hand. It would take a little bit of work, but it's definitely doable. But if instead the 20 was like 1,000, you definitely wouldn't want to do this by hand. So let's see how to do this using our formula. I've written down some steps that we can follow. The first step is to find n, a1, and an. a1 is our first term, which is 2, and then a sub n is our nth term, which is 20. And then we need to find n. Now you might be able to look at this or even count on your fingers and see that n is going to be equal to 10. But let's go ahead and let me show you how to do this if our last term was a lot bigger than 20. To find n, we're going to use the formula for a sub n. That formula is a sub n is equal to a1 plus n minus 1 times d. The reason we're using this formula is that we have n in that formula. So let's now plug in what everything is. A sub n is 20. A1 is 2 plus n minus 1 times d. Now, we weren't given d, but we can easily find d. If we go up here, the difference between these terms is going to be 2. So d is equal to 2. Now all we have to do is take this equation and solve for n. Let's pull this 2 to the left-hand side. So we have 18 is equal to n minus 1 times 2. Now let's divide both sides by 2. So we have 9 is n minus 1. And that tells us that n is equal to 10. Just moving the negative 1 to the left. Now we can use our formula for the sum. Let's go ahead and write down that formula. S sub n is equal to n over 2 times a1 plus an. And we have everything we need to plug into that. S sub n is then n, which is 10, divided by 2, times a1, which is 2, plus an, which is 20. So S sub n is equal to 5 times 22. That's just 20 times 5, which is 100, plus 2 times 5 is 10. So we get an answer of 110. The sum of this finite arithmetic sequence is equal to 110. Let's now look at our next example. This one is different. We want to find the sum of the first 50 positive even integers. Let's begin by writing down what those integers are. They are 2, 4, 6, all the way up to x, which is our 50th positive even integer. Let's go over here and look at our steps. Our first step is to find n, a1, and an. So let's see what we've been given. We know that n is equal to 50 because we want to find the first 50 positive even integers. We know our first positive even integer is 2, so a1 is 2, but we don't know what the last one is. So what we need to do is we need to find a sub n. And we're going to use the same formula that we did in our first example. We're going to use the formula a sub n is a1 plus n minus 1 times d, and this time we're going to find a sub n. Let's go ahead and plug in what we know. A sub n is a1, which is 2, plus n, which is 50. So we have 50 minus 1, and then d. Again, we weren't given d, but if we go up here, we can see that the difference between our integers is equal to 2. So our d is 2, and we can put that right down. This gives us 2 plus 49 times 2. So that's 2 plus 98, and that's going to be 100. Now let's make sure we have everything. We needed n, which we had. We needed a1, and then we need an, which we just found to be 100. So we're good to go. Let's go ahead and write down our formula. S sub n is equal to n over 2 times a1 plus an. S sub n is then n, which is 50. So we have 50 divided by 2 times a1, which is 2, plus an, which we just found to be 100. So this is 50 divided by 2 times 102. So this is 25 times 102. Let's see, 25 times 100 is 2,500, and then 25 times 2 is 50. So this is equal to 2,550. And that's what our sum is equal to. And that's it. You now know all about arithmetic sequences and how to find their terms and their partial sums. If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.